In Part 8 of the Unit 6 notes, we are going to be naming and writing formulas for covalent compounds. We will use the following rules when naming binary covalent compounds. The nonmetal, which has the most metallic character, is written first, and the ending of its name will not be changed. It should be closer to the bottom left corner of the table. Of course, we know this from our periodic trends unit. Metallic character increases towards the bottom left corner. The nonmetal, which has the least metallic character, is written second, and the ending is changed to IDE. This is similar to what you did with the binary ionic compounds. A prefix is added to each element to describe the number of atoms, except if the first element has only one atom. Mono will never start a compound name. If vowel combinations of O to O or A to O are next to each other, the first letter is left off. Nonmetals share electrons in many ways, so several compounds can be made of the same elements. There are no charges in covalent compounds, so we can't describe the differences between them using Roman numerals like what we did with the ionic compounds. The prefixes in the chart below, along with the rules from the previous slide, can be used to differentiate between different compounds. So we have each of our prefixes for 1 through 10 listed here. Our example on the left shows different ways that nitrogen and oxygen can come together. I could potentially have one of each, in which the name would be nitrogen monoxide. One of our rules stated that when there was one of the first element, we would leave off the mono. So mono is only ever used if there's one of the second element. Our second example has one nitrogen and 2 oxygens. Again, mono is left off for the first element, so just nitrogen. Di because there are 2 oxygens, and then oxygen changes to oxide. Next up, we have nitrogen trioxide because I now have 3 of the oxygens. In our fourth example, we have N2O. Because there is 2 of the first nitrogen, we need to have dinitrogen, so that shows our number of atoms. We have 1 oxygen, monoxide. In our last example, we have N2O5. Again, dinitrogen. Now that we have 5 of the oxygens, it would be pentoxide. Notice that the A from penta is cut off, so that we don't have the A to O combination. In our checkpoint, we are going to be going from formulas to names for each of the following. In our first example, we have a single xenon. So we write xenon. No mono for the first element. Next, we have 6 of the fluorines, and our prefix for 6 is hexa. So we write out hexa, and then fluorine goes to fluoride. In our next example, we have 2 sulfur and 2 chlorine. The prefix for 2 is di. So I have disulfur, di, and then chlorine goes to chloride. Next, we have a single sulfur, and then 3 oxygens. The prefix for 3 is tri, and then oxygen goes to oxide. In our next example, we have 5 selenium. The prefix for 5 is penta, like a pentagon. So we have pentaselenium. The prefix for 9 is nona. In this example, the A is going to be cut off because of the O combination after it. We have that A to O. So now we're just going to write out oxide. So pentaselenium, nonoxide. Next, we have 6, which is hexa. So hexa, iodine. And then 7 is hepta. So hepta, bromide. In our final example, we have a single hydrogen, and we do not include the mono prefix. But for the second element, we would. Iodine becomes iodide. When you are given the name and asked to write the formula for a covalent compound, you should first write the symbol for each element. Then write in the appropriate number based on each prefix for each element. Do not cross prefixes. This is not the same process as ionic formula writing. So for example, if I have tetraphosphorus decoxide, this is telling me that I have 4 of the phosphorus, so P4. Decoxide, dec means 10, so 10 oxygens. I would not cross the prefix to the opposing element. I would not put something like P10O4. All right, we are going to wrap things up here by going through examples of names to formulas. For my first one, I have carbon tetrachloride. If there's no prefix, that's the same as mono, 1. So I have a single carbon. Tetrachloride means that I have 4 chlorines, Cl4. Dinitrogen means that I have 2 nitrogens. Mono means 1, so I have a single oxygen. Iodine, no prefix, so I just have 1. Hepta means 7, so F7. Sulfur, no prefix, so just 1. Di means 2, so I have 2 oxygens, SO2. Tricarbon, so that means I have 3 of the carbons, tetranitride, 4 of the nitrogens. For the final example, we have tetraselenium. Tetra means 4, so Se4. And then hexabromide, so I have 6 of the bromines. This example is important because we know back in our ionic compounds we were supposed to reduce any of our formulas, and this could be reduced. You do not reduce covalent compounds. These molecules actually have each of these numbers of atoms within their structure. That concludes part 8 of the Unit 6 notes. When we come back for part 9, we will be talking about metallic bonding.